Ready, hey? Now we will be going to do the another one, which is the to find E due to a dipole on the equatorial line. Now first we need to understand what is equatorial means. Okay, now say, I'll make a picture. Say here is a dipole. Dipole means equal and opposite charge separated by certain distance. The origin is O. The perpendicular bisector of the dipole is known as the equatorial line. Now if we make the perpendicular bisector of the dipole, then this will be what? This is the equatorial line. And in this section we are going to find the electric field of the dipole on the equatorial line. Anywhere we can choose. Okay, we can choose here, we can choose down also. In general we are doing, let me choose it here. Okay, then as we did in the previous section, from the origin, that point we called, this is the equatorial line, so R in general we are doing. Then from the origin the distances are A and A, right? Now if we do the construction, this will be what? This will be this distance. This is a common. The two triangles are congruent. Hence what? These two sides will be equal. This is the isosceles triangle. Now as it is the perpendicular bisector, then this will be what? The hypotenuse, right? If we use the Pythagoras theorem, the hypotenuse of it will be what? This will be R square plus A square, right? Isosceles triangle it is. Hence this will be what? It will be the same, R square plus A square, right? Okay, now let's see what will be the electric field. Now what is the electric field due to the dipole? Now from the superposition principle we know that a total electric field at this point P will be due to minus Q and due to plus Q, right? Okay, now in the previous case, on the axial case, the electric fields, they were on the same line, right? Now in this case, will the two electric field on the same line? Let's see it. For this minus Q, what is the direction of the electric field? We'll assume the test charge along here, right? Because the test charge will move along this direction, right? So what is the electric field? This is directed along this. The length of the arrow represents the magnitude, right? And due to plus Q, what is the direction of this? Plus Q. Now you see, we need to add the two vector quantities, but their directions are different. Now what can we do? We have to use the vector resolution, right? Okay, now I'm doing a construction. What I'm going to do, let us resolve the component of E plus Q and E minus Q. Okay, all right. Now if this angle is theta, then this angle will be what? Theta, right? Okay, if this angle is theta, the construction which I have made, all right, can I call this as a x dash axis? Okay, if this is theta, what would be the measure of this? Theta. Let me I hope it is clear. Then if this is theta, this will be what? Theta. What is the reason? They are alternate opposite angle, as x dash x and q minus q, they are parallel. So I hope we can catch it this much. Okay, then okay, all right. Now E minus Q. Okay, we know it from the vector that if a quantity is a vector, then we can resolve it into two components. any perpendicular components, say this is y, this is x, right? Then the one who bears the theta, that will have cos of it, and the other one will have the sine of it. So e minus q, this, as it bear the theta along, then the component of e minus q along the x dash, this will be what? E minus q cos of theta, right? Okay. Similarly, then the other component of it, okay, the other component of it, e minus q, the perpendicular to x dash will be what? The y-axis. So this would be what? This will be e minus q sine of theta. This comes from the vector. Class 11 student, please. I hope you will be remembering it. Similarly, if this angle is theta, what would be the measure of this angle? Theta. Yes or no? Vertical opposite angles, right? Okay. Now similarly, as we did for e minus q, can we do the same for e plus q? Okay. If we do for the e plus q, let me use the other color so that it will be much more clear. E plus q along here, if we resolve it, then this will be what? As it bear the theta, so this will be what? E plus q cos of theta. My figure may not be that clear. Okay. Similarly, this will be what? E plus q sine of theta. Right? Now, what I did, let me make it. Okay. Let me make it in a better way. Okay. See, we had one problem. Okay. We had to add the electric field E minus Q and E plus Q. But one of the direction of E minus Q was directed along here, and E plus Q was directed somewhere here. Okay, means the directions were different. Then what we did, we used an idea of the vector. What we did, we constructed two perpendicular axes. The most common for us is the x and y, so we did it. Okay, in general you can use any two perpendicular axes. We used x and y. Then what we did, we split e minus q along the y-axis and along the x-axis, and similarly we split e plus q along the x and the y-axis. Now based on the geometry, the one term become e minus q sine theta, another become e plus q sine theta, then another one e minus q cos theta, then the same e plus q cos of theta. That means what? This do not exist. What exists? E plus q cos theta, e minus q cos theta, then e plus q sine theta, and another. So what? We had two directions. Okay, now both of them are in the same direction, so we can add them together. Now we will see what about this. Okay, now so this is a very important one. This comes from the principle of superposition, right? Now one thing, let us check individually what is the magnitude. We know that the directions of them are these, right, which we split it. However, what is the magnitude of e minus q and e plus q, right? Now magnitude, we write it as modulus. Okay, sometimes you see this way, sometimes you even see this way also. Both of them means modulus, means the magnitude. So I'm doing modulus of it. Now due to e minus q at this point, what is the electric field? That is what? A k q by, what is the distance between them? This is root over r square plus a square, this one, right? How much it is? This is kq. This is due to the electric field due to a point charge, which we did in the previous derivations, right? Similarly, E plus Q, modulus of it, what it is? Electric field due to the point charge at this point, right? Now what is that? This is also kq by, what is the distance of this point? This is how much? This is root over r square plus a square, and in the formula there was square, so this is the one, right? So this is kq by r square plus a square. Now you see it, 1 and 2, the magnitude kq by r square plus a square, kq by r square plus a square, both of them, the magnitude wise same. That means the magnitude of E minus q sine theta and E plus q sine theta are also the same, right or not? But they are oppositely directed, then what means? They are going to cancel each other. All right, means what? This component will now no longer going to exist. Okay, that is why our mathematics will become easier. So what is the remaining? The remaining is E minus q cos theta and E plus q cos theta. Both of them are having the same magnitude. Okay, now this equation number 1 in terms of magnitude, okay, in terms of magnitude, equation 1, what it becomes? Equation 1 will become what? E minus q cos of theta plus E subscript q cos of theta, right? See, I have removed the vector sign because now we are just talking about the magnitude only. Now E minus q and E plus q, magnitude of it are the what? Both of them are equal, right or not? Right? Both of them kq by r square plus a square, right? Then this is what? Both of them are same. That means, can I write E minus q? I hope student you will be following me in place. This also I can write E minus q cos of theta. I can do. Okay. Then this will be what? 2E minus q cos of theta. Right? Now mathematics. E minus q is what? K q by what? R square plus a square cos of theta, right? Cos theta, if we go from this triangle, okay, cos theta will be what? Base by hypotenuse, right? Isn't it? So cos theta is equal to base by hypotenuse. And what is the base? Base is a and hypotenuse is what? R square plus a square. Okay, now you might be surprising why I have taken in place of cos theta this value. Actually, here the given parameters in general are a and the distance only and the charges of the dipole. Okay, theta and these are all we constructed, okay, for that reason. Okay, now this will be r square plus a square root over r square plus a square. What it will be? This is I can write k, okay, 2a q by r square plus a square to the power 3 by 2. You can check this one. Okay, now have we seen this one before? This is what? Dipole, right? Okay, so this is equal to E is equal to what? Kp by r square plus a square to the power 3 by 2. Okay, Now, can I write it in terms of vector? Okay. Now, what is the direction of electric field? The direction of electric field is x-axis, x-axis, right? And what is the direction of the dipole? The dipole is from negative to positive, right? Then in terms of here, what I can say, electric field is equal to minus, okay, K P by r square plus a square to the power 3 by 2. Now, why this minus sign? This minus sign says the direction of electric field is opposite to that of the direction of the dipole. This is quite evident even from here. As I'm saying, dipole is from negative to positive, electric field is along here, so the directions are opposite. Okay, so this is the expression of electric field due to the dipole on the equatorial line. Okay, then one more thing, then same in the similar way we will come to the special case. Okay, okay, let's go to the special case. Special case. If actually this is the general case, if r is much larger than that of a, then what will be the expression of electric field will become? What was the expression? K P by r square plus a square to the power 3 by 2. If r is much larger, then what we can do? We can neglect a square, right? What we can do, let me write it. We can neglect a square. What is the reason? If r is much larger, then a square will be further smaller, right? Compared to r. Then if we neglect it, then what it will become? This will be K P, then this term will no longer be there, then this will be what? R square to the power 3 by 2, and this will cancel out, then K P by R cube. Okay, now do you remember for the axial line what was it? This is, let me write it as E equi. Okay, for the axial line, if you remember, what was it? It was 2k p by r cube, right? Okay, that means axial line, in the axial line, the electric field will be double to that of the equatorial line, right? Yes or no? Okay, so what could be so let me write the same thing again here. Okay, in terms of vector, I can make this one. Here is minus, right? If we choose the axial line, in terms of vector, this will be 2k p by r cube, right? Then this E axial is equal to, okay, in place of this, can I write minus equatorial? Okay, so minus 2 to equatorial. Okay, fine. So where the electric field is stronger, on this negative sign only tells about the direction. Okay, axial line, what is the direction of electric field? Along here, right? Equatorial line, what is the direction of electric field? Opposite to it. This minus doesn't say less, it simply says about the direction. Okay, so on the axial line, if this is the direction of electric field, on the equatorial line, this is the direction of the equatorial, this one. what about the magnitude? On the axial line, okay, for the same distance, let's say, let me little bit elaborate it, minus q plus q. Okay, the distance r, here is also r, here is also r, the same distance. Okay, in the axial line, if the electric field is, for the same distance, if the electric field is, let's say x, then on the equatorial line the electric field will be what? X by 2, right or not? Equatorial line electric field is half of that of axial. Okay, so you need to remember these few informations for the exam point of view. Electric field reduces strongly on the equatorial line than that of the axial line. This is quite evident also because we have seen that on the equatorial line the sign factors were cancelling each other. Okay, so students, remember remember it, this one, remember it, this one, remember this one. Okay, remember k is 1 by 4 pi epsilon. Thank you.